Very good morning, guys. Today we are going to continue our series part 2, acids, bases and metalloids. Radioactivity. This is the process of emission of particles from the nuclei because of nuclear instability. Inside the nucleus, the atoms are unstable. That's why it emits some rays, invisible rays. That is called radioactivity. Radioactivity rays. Okay. Likewise, radioactivity is a nuclear phenomenon that happens naturally because nuclear instability. As I said, it's happening because of nuclear instability. In 1896, Henry Becquerel first observed the phenomena of radioactivity, and the term radioactivity was coined by Marie Curie. Okay, very important. The year also very important. Radioactivity or means 18 into 2 36. Okay, 6 18. It starts with 18 6 1896. Okay, just rotate it. Rays will come rotate. Okay, 1896. This is a shortcut for this to memorize it, because like MTS and Group D exams, they will ask particularly year to confuse the candidate. Okay, we will tackle that also. We will strongly focus on year wise also. Okay, Marie Curie discovered the radioactive elements, namely polonium, radium, in 1898. For his discovery, she got Nobel Prize. Okay, M after N. Marie Curie got Nobel Prize. Marie Curie got Nobel Prize for her experiment in PR. Okay, polonium, radium. PR, that is for polonium, radium. Okay. After a long years of experiment, Ernest Rutherford along with his colleague. Okay, these names are not important, but we will see once at a glance. If they ask, it is helpful for to eliminate in our option. Okay, Ernest Rutherford along with his colleague Hans Geiger and his student Ernest Marsdell. Okay, Ernest, two Ernest people are in her name. Okay, Ernest Rutherford, Ernest Marsdell, and Hans. Both are drinking ginger tea. Ginger, like that. Okay. Types of radiation and penetration. In the types of radioactivity rays, it's varies, depends upon its penetration level also. Okay. First, alpha rays, beta rays, X rays, Y rays, neutron. Okay. In alpha rays, alpha rays, two protons, two neutrons, tightly packed together. We know if the atom tightly packed together, weight is high. If weight is high, the speed traveling is low. Okay. Alpha particles are being released during radioactive decay from the nucleus radionuclides. The alpha particles are identical to nucleus. That are identical nucleus. Which nucleus? Helium atom. We know the helium 2 4 I think. Double ionized helium atom. Okay, I said na. Helium. Okay, in comparison to other particles, compare it alpha rays comparing to gamma or beta. Alpha is heavy, as I said, alpha is very heavy. The very range in air, very small range in air. Low speed alpha particles have very weak penetrating powers. These particles are even stopped by thin paper. It is very slow. That's why even we placed a thin paper in it, okay, it can stop. Okay, it have double positive charge. Alpha particles are highly ionizing. Okay, here important points to remember: 2 proton, 2 neutron, 2 plus 2 4, alpha. Forget this. Alpha 1 2 3 4, 2 proton, 2 neutron. Alpha is first coming na? In this order we know alpha, beta, gamma. Alpha is first, that's why overhead weight is high. Because of it, unable to run. That's why it is very slow. Beta particles are the fast moving electrons emitted by some radionuclides. During the radioactivity decay, this is called beta decay. Beta particles are of much lightweighter and carry single negative charge. Okay, this is the symbol of beta. -1. This is proton. This is neutron. -1 plus 1. It tallies as 0. Okay. Comparing to, this is very less weight, so it can travel some distance. Comparing to alpha, it is little more faster. Okay, it can stop by several sheets of paper or one sheet of aluminum sheet is little bit thinner comparing to the normal sheets. That's why we place over 5 or 10 sheet of papers, it is equivalent to one sheet of aluminum foil. That's why it came. Okay, gamma particles are the bundle of high energy, namely electromagnetic energy, photon. Electromagnetic energy, gamma, GAMMA, gamma rays, magnetic, electromagnetic. Okay, M is the electromagnetic. Among all three particles, alpha, beta and gamma particles are the most energetic because it has 2m. That's why it is most energetic. Electromagnetic, 2m to form electricity. This way it is more powerful. Gamma particles, which are the form of electromagnetic radiation, short form is EM, or originate from the nucleus. The wavelength of the gamma rays are shortest. Important. Wavelength are shortest. Okay, gamma wavelength. This is called wavelength, right? This symbol is called wavelength. If it is very slow, it will go like this. If it is fast, it will go like this, like this. So the wavelength is very short. No, short size is very smaller, na? That's why it's very short. Uses of radioactive elements. Radioactive elements are used in medical field. In medical, for time pass, they will use radio to hear sounds. Industry works are going to reduce the pressure. They will play sounds. Energy production. In our body, cells are playing radio and enjoying and creating energy. Okay, nuclear reactors. Just for example, this is not in reality, this is just for example to memorize or mnemonics, like mnemonics. Okay, radiocarbon dating is a method to identify the age of carbon. Okay, uranium dating is used to determine the age of the earth, minerals and rocks as usual. Half-life is nothing but radioactive substance remains half, and that time radioactive substance remains half only, not original amount, or it is half of the original amount. Relation between time and half-life. Time is equal to n into t 1/2, or half of the time, right? N into t 1/2, or n is equal to n0 1/2 n. Okay, half of the n, not full n. 0 means full, not full n, only half of the n. n0 half of the n. Okay, radioisotopes and their uses. Some of the radioisotopes are used very in medical field. Some other field, it is very important. Iodine 131, iodine 131 used for thyroid. We know thyroid gland, we will use iodine. Okay, but iodine 131, this is the particular radioisotope. Important, note it down. Iodine, I, it start with I. Okay, it will end in E, right? This is E. We can put it as this side, 131, iodine 131. That's it. Then iodine 1 2 3. If we count 1 2 3, right? 1 2 3, our brain immediately start to running race. Brain imagine 1 2 3. When we see 1 2 3, our brain imagine as running race. Cobalt 60 external treatment for cancer. Okay, C cancer, cobalt cancer. Okay, cobalt cancer. 60 age, at the age of 60, people are getting cancer, age of 60. Sodium, Na24, value of N14, we know, right? Alphabet series, N value of N14, add 10. Okay, that's it, 24. Then sodium 24 is used for salt solution to trace the flow of blood. As we know, sodium as salt is used to flow of blood. How can we remember? Sodium is salt used to cook. We know, right? In our village, we will cook the blood of goat. Just for imagination. Sodium 24 is for salt solution to trace the flow of blood. Just for imagination. Phosphorus 32 used for leukoma, leukemia therapy. Okay, leukemia therapy is nothing but look is a word for white blood cells, immunity related things it will come. Okay, pass we know pass it's like a sweet, 1 rupees I think. The price of the pass is reducing 322 221. Okay, so the number should be phosphorus 32 is used for leukemia. If we eat pass, our immunity will increase. Okay, next, nuclear reactions. Nuclear reactions release tremendous amount of energy. It release plenty amount of energy known as nuclear energy. While nuclear reaction, it releasing some tremendous amount of energy, that is called nuclear energy, which are being used to produce electricity in a nuclear plant. Okay, the nuclear energy normally produced by nuclear fission, fusion and nuclear decay. While nuclear reaction is occur, okay, 3 types of nuclear energy produced: nuclear fission, nuclear fusion, nuclear decay. In like MTS exams, they will ask the examples of this nuclear fission, fusion, decays. It is very important. In 1938, German chemist Otto Hahn, Fritz Strassmann and Australian physicist Lise Meitner conducted the experiment in which the products of neutron bombard uranium. Okay. 1938. Otto Hahn, Otto Schutt, Strassmann, Grassmann. Then Meitner, relating to that. They three, Otto Schutt, Grassmann, Meitner, experiment in product of neutron bombard uranium. Okay. As the result of this experiment, the relativity tiny neutrons split the nucleus of the massive uranium atom into 2 rough equal pieces and release massive energy. Okay, in this experiment, the uranium part split equally and produce massive energy as shown in this image. The nuclear experiment of Otto Hahn and his colleagues are popular as nuclear fission. This is called nuclear fission. Fish. Okay. We will cut it by this off, like this. Both equal pieces are like, this is one piece, this is center that bone, this is one piece. Okay, 2 pieces, we can split it into 2 pieces, that is called fission. Bombardment driven process that result the collision of I think fission, collision of 2 subatomic particles. This is two atoms, right? It will hit each other and it will collide, it will create one massive, that is called fission. In nuclear reactions, a subatomic particles collide with an atom nucleus and causes changes to it. Okay, nuclear reactions are thus driven by the mechanism of bombardment, not by the relativity constant, exponential decay and half-life. As we see the half-life in that, characteristics of spontaneous radioactive process The first ever nuclear reaction in which one was element was changed into another element is carried out in 1919. Okay, both same. Sorry, both like similar atoms hit it together. Okay, 1919. As we see 1919, what comes in your mind? Monto claims Ford Act 1990. Okay, in history and politics. Nuclear fission is a radioactive. Oh my god. Okay, sorry. As I informed first, that is correct. I had a little bit confusion in it. Now it is clear. Nuclear fission is a division of two. Okay, fish. We can divide the fish. Okay, that is called fission. Okay, nuclear fission is a nuclear reaction or radioactive decay process in which the nucleus of an atom splits into smaller and lighter nucleus. Very sorry guys, in this part now it is very clear. Okay, hereafter no more confusions. Nuclear fission, fish, we can divide the fish. Okay, division of the atoms. Okay, the fission process often produces free neutrons and releases very large amount of energy and energetic standards of radioactive decay. Example: 2 3 5 2 plus 3 5. Okay, isotopes of uranium break down into when the neutron is bombarded unstable. 236 uranium, it will further break down into krypton and barium. Okay, and with the release of large amount of energy and 3 molecules of neutrons. Okay, these neutrons will further lead to chain reactions of breakdown of releases of high amount of energy. The nuclear power plants, the reactions are controlled process. Nuclear power plant, nucleus very small, it will control in our hand. Okay, controlled process. Types of nuclear fission: chain reaction, fission reaction. When a single nuclear reaction causes one or more subsequent nuclear reactions is known as chain reactions. It will goes not only this chain, it will only one reaction, it will goes multiple chains, that is called chain reactions. Such a chain reaction increases the possibility of self-propagating series of nuclear reactions. The nuclear chain reactions release million times more energy per reaction that other chemical reactions, because other chemical reactions are single reactions. This is goes under chain, right? It will create tremendous or plenty amount of energy in this. It is also known as the explosive and uncontrolled chain, because it is going uncontrolled, right? It will be explosive massively and destroy everything. When a heavy atom experiences nuclear fission, it normally breaks into 2 or more fission fragments. During the process, several free neutrons, gamma rays and neutrons are emitted and ultimately a large amount of energy released. Okay, this is the 2 examples. Just we read it once. This is very high level, but not necessary. I think in this level examiner will not ask. Okay, U235 uranium neutron fission fragments 2.4 neutrons plus 192.9 MeV. Okay, 235 Pu, that is plutonium, neutron fission fragments plus 2.9 neutrons plus 198.9 MeV. Okay, in atom bomb, chain reaction technology is used in atom. Very important. Atom bomb is an example of nuclear fission. Okay, in ATO, we will go by ATO for fishing. Okay, for fishing we will go by ATO bomb fission. Atom bomb 235 or Pu 239 are used as a fuels. Okay, 235 uranium 235 plutonium 239 are used as fuels. Fission reaction. This reaction in which neutrons produced by fission and of fuel atoms and are usually induce yet more fission for the release of sustainable energy is known as fission reactions. Okay, it is used as some renewable and sustainable energies, that is called fission reactions. In such reactions are slow and controllable. There are also known controlled chain reactions. Okay, the power electricity producing nuclear reactor is an ideal example of controlled chain reaction. Okay, if we have chain in our hand, okay, we have chain, this big chain, dark chain in our hand, it is controlled by our hand. Okay, this is our hand. If we put in electricity, okay, shock will come, na? That's it shows us controlled chain reaction. Okay, based on the properties of types of usages, fission or controlled chain reaction is classified as power reactions, research reactions, breeder reactions. Okay, these power reactors generally convert kinetic energy into fission products into heat. Further, the heat is used to heat or working fluid that drives a engine, which ultimately generates mechanical or electrical power. Okay, nuclear fusion, important. This is process of small atoms collide and create a massive energy. Process in which smaller atoms put together in the form large molecules with the release of high amount of energy, even more than fission reactions occur in the presence of sunlight. Very important, presence of sunlight. In this process, two light nucleus are fused to form heavy nuclear fission. During this process, tremendous amount of energy. Okay, hydrogen bomb, very important. Hydrogen bomb, hydrogen, we are using some gases. Okay, we are in LPG also, we are using compressed form of gases. That's why if it blast, it will go, it will destroy, completely annihilate the house. Okay, that's why here also gas we are using. In that atom, we are going by atom, we are safe in position. That is called fission, to fishing. But here we are using hydrogen, so this is fusion. Two hydrogen, simple example, hydrogen plus hydrogen to form helium. This is called fusion. These reactions comes under in sun. Okay, hydrogen bomb is about 1000 times more powerful than atom bomb. Okay, sun's energy is due to nuclear fusion. Very important. This is we what covered. Then it is initiated with neutron. It requires extremely high temperatures. Okay, can be controlled with cadmium. A controlled process. Fusion is a controlled process. This is controlled by cadmium. Is a controlled process. Produce radioactive waste. Only product is helium, which is not radioactive. Uranium 235 acts as a primary fuel abundant in Australia. Okay, uranium, AUS, Australia, uranium. Okay. Produce more energy than fission. Very important. Fission. This is fuse, electricity fuse. This is very less harmful. Electricity fuse is very high powerful. Nuclear reactors. For controlled process, we use nuclear reactors. We use controlled rods as cadmium, boron, silver, indium or zirconium to absorb the excess neutrons. Okay, here we are using these controlled nuclear reactors. Heavy water, D2O, very important. D2O, in asking which are the following is heavy water, as H2O, D2O, these options will be given. D2O is correct answer. Okay. Heavy water, deuterium oxide, graphite are used as a neutron moderator to slow down the reactions. These are used to slow down the reactions. Okay, these are used to slow down the reactions. Coolant in nuclear reactor is used to remove heat. Okay, if the nuclear reaction is occurs, the definitely heat will produce. For that we need to reduce that. That way they are using coolant. Okay, it may contain sodium or heavy water or an alloy of sodium or potassium as coolant. Sodium or potassium, NK, sodium or potassium as coolant. Metalloids, it possesses the characteristics of both metal and a non-metal, that is called metalloids. Okay, metal is high conductor of electricity, right? That's why it is semi-metal, so it is less comparatively. This is less semiconductors. Okay, good word is to express semiconductors. They are important in digital electronics. Okay, semiconductors in digital electronics: boron, silicon, germanium, arsenic, antimony, tellurium. Okay, how can we memorize it? A, B. Okay. Okay. Let me give one trick to this. Boss. Okay. GT. Gujarat Titans. Boss. Okay. Boron. Boss. Arsenic. Antimony. Silicon. Boron, arsenic, antimony, silicon. Boron, arsenic, antimony, silicon. Boron, arsenic, antimony, silicon. Germanium, tellurium. GT. Boss, GT. Okay. In question they will give me the given following options. Please select metalloids. Okay, in options: boron, silicon, germanium, copper. In options: both, all, 1, 2, 3 are correct. Okay, immediately we can apply our formula. Boss, GT. Copper, no C is there. Okay, we can choose B. Yes. Okay, this is the answer. Important chemicals and its compound. Okay, hydrogen chloride, HCl, found in our stomach. Okay, HCl is found in our stomach, used for digestion for food. Sulfuric acid, often referred as king of chemicals, has applications mainly in car batteries, detergents, fertilizers. Okay, let me give one shortcut. Sulfuric acid, king of acid, right? Car, sul. Okay, chal means water. Water will give run by flow fast, right? Chal fast, very fast. Chal, car will move very fast. Sulfuric acid, chalo, like that they will say na. Detergents, fast, very fast, it will clean it. Fertilizers, very fast, plant will go fast. Sulfuric acid is something fast is there. Car batteries, fertilizers, detergents. Okay, acetic acid, main formula, if we see CH3COOH, it is acetic acid. Don't be afraid of these formulas. We can use it regularly, and we can if we use it regularly, no need to memorize it. It will automatically store in our brain. Okay, no need to. When we saw that question, it is very easy to pick the answer. Okay, then citric acid. Okay, sorry, acetic acid is vinegar. Okay, it's all we know basic. Citric acid present in lemons and citrus fruits. Sodium chloride. Okay, this is common salt we use na, NaCl, sodium chloride, common salt we are using in our kitchen is common salt. Benzoic acid, preservation of food. Benz car, AC is there. If we put food, it will preserve for sometimes preserve. Okay. Sodium carbonate, we all know using salt we can wash car. Yesterday we saw that washing soda. Okay. Nitric acid, commonly used in manufacturing of fertilizers like ammonium nitrate. Very important. Nit ammonias ghost ammonias will come. Ammonic acid in fertilizers. Sodium hydrogen carbonate, it is we sometimes other name was sodium bicarbonate. This we use in baking soda. Actually we know sodium hydrogen carbonate, sodium bicarbonate. Okay. Baking soda, for cooking we are using salt, water and carbohydrates. Sodium hydrogen carbonate. Formic acid, it is food preservative. Already we saw one preservative, that is benzoic acid. This is formic acid. Farmers can store grains as preservative. Okay. Potassium hydrase. Okay. Caustic potash. Okay. Potassium hydrase. Potato, we are deep in water and sell. If we sell normal potato, it will comes per kg 20 rupees or 30 rupees. If we put in salt water and something, we added the value of the potatoes, we can sell one potato piece as 40 rupees. This is okay. It is very costly, right? Potassium hydroxide, potassium water, costly potash. Okay, just for memorizing. Boric acid. Okay, boric acid, very bore, hydrogen borate. If we are in bore, we will play in candle, we will put our finger like this, no heat will come. Okay. Flame deterrent. Okay. Flame to memorize the flame of that candle. Okay. Antiseptic. Okay. Antiseptic, just memorize it. In Dettol. Okay, we will play in when we are bored time, we will mix water and Dettol, it will change white color. Okay, we will play in bored time. When we see the boric acid, we will immediately we need to memorize antiseptic. Dettol is antiseptic, right? Then antiseptic, then flame retardant. Okay. Then magnesium hydrate, magnet plus water. Okay, magnet plus water, milk of magnesia, commonly used as antacid. Okay. Milk of magnesia, magnesium. Okay, how can we remember this? Okay. In water, in milk, we can mix some magnet to absorb our acidity in our stomach. Our stomach is J-shaped. Okay, our stomach is J-shaped. It seems like this, kidney bean. Okay. In acid, it will sucks. That's why milk of magnesia, magnesium hydroxide, antacid. Okay. Aluminum hydroxide, foaming agent in fire extinguishers. Okay. Allu Arjun, when Allu Arjun comes, fire, Puspa means fire, right? Fire will come, we can use take immediately, security guards take fire extinguisher. Okay. Aluminum hydroxide. Potassium nitrate. Okay. Potassium, potato stuck in night, we can fire matchsticks and gunpowders to save the potato in night. Okay. Okay guys, we will see the in next video. It's already crashed 40 minutes. Please stick with our content, don't be it seems like it is 40 minutes, but we are covering very little content in that 40 minutes, because this is more crucial topic. They will ask questions directly. That's why I am giving the shortcuts and everything to you. You just watch my videos regularly. You can repeat it, you can revise it very. I am teaching when what the tricks I am using to memorizing it, I am giving to you. I am giving to you very everything. I'm giving to you guys. You just need to study and strictly follow my schedule. Definitely we will crack this coming NTPC, Group D, MTS, CHSL, everything. Upcoming exams we need to crack everything. Okay, there is no more excuse. Just follow it. Thank you.